Assalamualaikum and good day to all. My name is Alia Sofia binti Muhammad Zan. Today, my group will be presenting our product which is soap level detection and monitoring system, collaborating with MZ Car Wash in Sri Serdang, Selangor. Without further ado, let's get started. First section is problem statement. We conduct our first site visit to MZ Car Wash on 10 April 2023 to survey and investigate the process involved in the business that may affect their productivity throughout the day. We then came across with the process of refilling soap in the snow foam tank. The snow foam is used to soften and remove dirt from the car for a more effective wash. It is kept in a pressurized tank connected with a compressor in order to produce the foam. Without the tank, the process had to be done manually, which is by preparing the soap mixture and apply it by hand. This manual method is said to be time and effort consuming to the worker. With that being said, the snow foam tank can be claimed as a crucial component to the car wash. Current method used in the refilling process is to first sway the tank from side to side. From there, the worker will estimate the soap level left. And if the worker estimates that the soap level is running low, soap mixture will be added to the tank. The process is proved to be troublesome as they need to sway the tank for every inspection and only rely to estimation for the result. As different workers have different perspective, the level where they determine the soap should be refilled will vary every time. In this method, not only it is not ergonomic and productive, but also may affect the monthly cost in buying the soap essence. Therefore, the first objective of this project is to gather the user needs and convert them into technical requirements. Second is to develop a design concept that can ease the soap inspection process. Our proposed solution is to implement IoT to assist detecting the soap level in real time. This is the 3D CAD model to visualize the system to be developed. The system comprises of three major parts, which are the snow foam tank itself, the float switch sensor, and the IoT components. The tank is an existing product at MZ Car Wash. The float switch sensor is the most critical unit of the system, where it is responsible to detect the soap level in the tank. The sensor is then connected to an IoT system where the information received from the float switch is converted into digitalized data to be displayed on the mobile phone or to be shown through LED light.
Hello, I'm Deepanraj Ganesan from 4BMFI. My humble salutations to the viewers. Today I would like to explain about the stress analysis of enclosure of Arduino Uno. For this analysis, I stated the dimension and the thickness. This analysis also includes the determination whether the enclosure can bear the stresses without deforming, cracking, or compromising the inner components of the Arduino Uno R3. Fabrication plan. Fabrication plan is divided by two divisions. The first one is about the list of components. The second one is about the manufacturing process. List of components is consisted of 7 major components, which is starting from PP float switch, Arduino Uno R3, USB cable type A to B, male-to-male jumper wire, LED, resistor ohm, and casing. Furthermore, the fabrication plan is also explained about the manufacturing process. Manufacturing process also divided by two divisions. The first one is PP float switch fixing and the second one is sealing the casing. There are 5 steps for PP float switch fixing. Begins from the material preparation, hardware installation, inserting source coding, checking the mechanism, and the final one is about the inserting the IoT system in the casing. In a simple manner, there are 9 steps for the sealing the casing for Arduino Uno, which is attaching to soap container. Begins from gathering the required materials, preparing the Arduino Uno, choose some suitable casing or enclosure, plan the placement, apply sealant, positioning and secure the Arduino, seal the gaps allowing the sealant to cure, and the final step is testing for waterproofing.
A very good day to all. My name is Ngo Sheng Han. Today, I'm going to present about the circuit diagram of our product. First of all, there are 6 main components in a circuit. Firstly is Arduino board. It is a microcontroller providing processing power. The second main component is water level sensor module. In our case, we use float switch. It is used to detect water levels. The third main component is LED. It is a visual indicator for displaying the water level and to remind and alert operator to refill it. The fourth main component is a resistor. It is a current limiter resistor for the LED. The fifth component is breadboard. It is a platform for physical connections. Last but not least, there are jumper wires in the circuit. It is used to connect the components in the circuit. The circuit connections are crucial for the process success. Firstly, the positive terminal of the water level sensor module is connected to the 5-volt pin on the Arduino board, supplying power to the sensor module. Then, the negative terminal of the float switch is connected to the ground pin of the Arduino board, completing the ground connection. To integrate the LED, the legs is connected to a digital pin on the Arduino board, typically pin 13. This pin is responsible for controlling the LED behaviors. The other leg of the LED is connected to a current limiting resistor. This resistor protects the LED from damage by regulating the current flowing through it. Finally, the other end of the resistor is connected to the ground pin of the Arduino board, completing the circuit. Now, I'm going to present about the user interface design of our product. There are 5 main pages or screen in our user interface. The first one is Home. It is a main landing page with an overview of SOP level alerts. The second page is SOP level, detailed display of current SOP level and visual indicators. The third one is history of water levels. It is a graph or chart showing SOP level history over time. The fourth page is settings. It is a configuration options for customization and preference. Last but not least, the user interface got help page. It is for user guides, FAQs, and support information. That's all from me. Thank you.
Assalamualaikum and hi, my name is Nur Najiha binti Asni. In this video, I will explain about ergonomic analysis and system usability skill. Conducting ergonomic risk assessment is the first step to reducing occupational ergonomic injuries. The goal of this assessment is to identify ergonomic risk factors so we can make a process improvement to reduce their presence in the workplace. To ensure the workplace is safe, we have round out the best ergonomic assessment, which is ruler analysis. The ruler method was utilized for postural analysis to determine the severity of a posture. The risk factors are combined into one total score using the ruler method, which range from 1 to 7. It's look at the severity of each risk factor. According to ruler method step, the working posture of each component will be analyzed as follows. 1 is assessing posture for group A, upper arm, lower arm, wrist twist. Second, adding muscle use and force score for group A. Third, assessing posture for group B. Next, trunk and leg. Fourth, adding muscle use and force score for group B. Fifth, determine ruler grand score and action level. Ruler analysis were performed based on figure A and B. Figure A shows the posture of staff refilling the snow tank. Meanwhile, for figure B shows the posture of staff checking the soap level. The descriptive method of analysis is utilized to provide an assessment of the body part that are thought to be injury prone and anything that makes worker adopt awkward posture. The working posture that require improvement based on the result of the ruler assessment can be given the suggestion improvement based on the analysis. The table shows the ruler analysis description. The risk level of each awkward posture will be further examined after it has been evaluated by using the ruler method. A working posture has medium risk level if the ruler grand score is 5 or 6. Based on the assessment of ruler that has been done, a final score of 6 in ruler assessment for the staff refilling the snow from tank and staff checking on the car soap level, which require further investigation and possible changes on the design to reduce the risk of MST injury. System usability scale is a questionnaire that is used to evaluate the usability of product and service. These survey questions are used as a quantitative method to evaluate and get actionable insight on the usability of a wide variety of the new system, which may be either software or hardware. For our project, we will use a product as a reference in the context of the question. The following 10 questions form up the system usability scale, which can be answered on a 5-point scale ranking from strongly disagree to strongly agree. Figure shows the sample of system usability scale question that we create by using the Google form. After we create the question, we share the link to the 4 respondents, which are the staff of car wash, and then they are asked to score the following 10 questions with 1 of 5 responded range from strongly agree to strongly disagree. After that, the system usability scale is to be calculated for each of the respondents. Here are the quickest and simplest steps to do so. First step is convert the scale into number for each of the 10 questions, which are strongly disagree is 1 point, disagree is 2 points, neutral is 3 points, agree is 4 points, and strongly agree is 5 points. Next step is calculate the X, which is sum of the point for all odd number question, and Y is sum of the point for all even number question. X naught is sum of the point for all odd number question minus 5, and Y naught is 25 minus sum of the point for all even number question, and system usability score is X naught plus Y naught multiple with 2.5. After we calculate, we will get the result of system usability scale. The system usability scale can be used to determine how well the usability performed in terms of effectiveness, efficiency, and general usability. The average grade, which is grade A, was given by respondent A and B. It shows that they are satisfied with our service and product. However, for respondent C and B, they gave our product a D grade, showing that we need to adjust and improve the product design as they were not very satisfied with it.
My name is Muhammad Ashrin bin Halim. I will explain about cost analysis. So, cost breakdown structure to provide a comprehensive view of the various cost component involved, including cost material that we calculate for Arduino Uno, USB cable type A to B, alarm, LED, male-to-male jumper wire, resistor 220 ohm, pump control, tank water level indicator. So next, for development cost, is include design, software, and testing. So here is the table represent the calculation of material cost for soap level detection and monitoring system. So here is other calculation for development cost, utility cost, maintenance cost, and labor cost for soap level detection and monitoring system. And we managed to get the total cost. So this is the break-even analysis for our project. The break-even analysis calculate the level of sale or production needed to cover all costs, both fixed and variable. So from the calculation, we got 8,000 with 4 units to cover all the costs. Strategy to a sustainable product design. First, material extraction. Use sustainable and eco-friendly material. Choose sustainable eco-friendly material for snow wash tank. Minimize environment damage. Reason, environment impact. Eco-friendly material reduce environment effect from commodity extraction and manufacturing, including deforestation, pollution, and carbon emissions. Second, production. Choose eco-friendly snow foam tank materials like recyclable plastic of sustainable alternative. Reason, snow foam tank production reduce carbon footprint and ecosystem harm through the eco-friendly material. Third, transportation. Improve warehouse power generator by utilizing renewable energy such as solar, wind, and reduce electricity usage. Reason, this can reduce harmful emission to the environment significantly. Fourth, usage. Soap tank level sensor. Choose a reliable sensor for accurate soap tank measurement and integration with monitoring system. Reason, the soap tank level sensor is secure for real-time data and reducing waste by overflowing the tank. Last but not least, end of life. Recycled tank reduce environment impact by reduce virgin material extraction. Reason, recycling reduce energy consumption, improve air quality, and reduce greenhouse gas emission.